homogeneous lamina is called the centroid of the lamina. Here, in the case of a homogeneous lamina, the density function delta is a constant. Density function delta is a constant for a homogeneous lamina. The centroid of a homogeneous lamina is calculated by the formula x bar equal to double integral over r x dA divided by double integral over r dA. That means this is same as double integral over r x dA divided by area of r. Similarly, we have y bar equal to double integral over r y dA divided by double integral over r dA. This is equal to double integral over r y dA divided by area of r. Okay, now let us move to a problem for finding the centroid of a homogeneous lamina. So the first question is, find the centroid of the semicircular region shown in figure. The figure is like this. So here we have to draw a semicircular region. Semicircular. Okay. Just to do like this. So here A, here minus A, here our x-axis, here our y-axis. Now we can mark the region of integration. The region of integration is this one. This is our required region. Now we can mark the region as R. Okay. Now here you can see that this semicircular region is symmetric about y-axis. Okay. So by symmetry, x bar equal to 0. Since the y-axis is obviously a line of balance. Since y-axis is a line of balance. Okay. Now we can find the y bar. Y bar equal to double integral over r y dA divided by area of r. Area of r. Okay. So this is equal to double integral over r y dA divided by, now here area of the region r. We know this shaded region is semicircular. Okay. And we know the area of a circle is given by pi r square. Here the radius is a. So pi a square. That is the area of a full circle. Here we have to consider the semicircle only. So area of the semicircle is half pi a square. So you can write half pi a square here. Okay. Now that is equal to, now you can take this 2 in the numerator, then pi a square, then we have only double integral y dA over the region R. Now we can calculate this integral by converting this into the polar form. In polar form, x equal to r cos theta, y equal to r sin theta, and dA equal to r dr d theta. And here you can see that the radius varying from 0 to a. The smallest radius is 0 and the maximum possibility of the radius is a. So r varying from 0 to a. For that you can draw a radial line like this. Okay, you can draw a radial line like this. Okay, now here the angle theta varying from, you can see that the angle is measuring from the initial line. Initial line means x-axis. So the angle theta, the lowest value of theta is 0, and here we measuring the angle from the x-axis, and gradually that increases up to this point, and here at that point theta is pi. So theta varying from 0 to pi. Now that is equal to 2 by pi a square, then y is r sin theta. So r sin theta, dA is r dr d theta, and here r varying from 0 to a and theta varying from 0 to pi. Now there remains the integration only. So this is equal to 2 by pi a square. Then first we can integrate with respect to r. Here r, here also r. So r square. Now integral r square, that means r cube by 3, and that is from 0 to a. Now there remains d theta. So this is equal to 2 by 3 pi a square, integral from 0 to pi. Now here we have a cube only. That a cube here we can write here. Okay. So there remains d theta only. Now again we can integrate. So this is 2 by 3 pi. A is here. Then integral theta. That means 0 to pi. So the answer is 2a by 3 pi into pi. That means the answer is here we missed one sin theta. One sin theta is here. Okay. So okay. So this is equal to 2 by pi a square, integral from 0 to pi. First we can integrate with respect to r. So sin theta is a constant. So integral 0 to a r square dr, then d theta. So this is equal to 2 by pi a square, integral 0 to pi sin theta, then here r cube by 3 from 0 to a d theta. So this is equal to 2 by 3 pi a square. Now we can substitute the upper and lower limits for r, so that become a cube only. Now there remains integral 0 to pi sin theta d theta. Okay, so this is equal to that is equal to 2 by 3 pi. Now we can cancel one a square. So a is here. Now integral sine theta, that is minus cos theta, and here theta varying from 0 to pi. So this is equal to, here cos pi is minus 1, cos 0 is 1. So here 2a by 3 pi minus is there. Now cos pi is minus 1, then minus cos 0 is 1. So the answer is 4a divided by 3 pi. Okay, so our centroid is equal to x bar, y bar, and x bar is 0, y bar is 4a divided by 3 pi. Okay, so this is the method of finding centroid of a homogeneous lamina. Okay, thank you all.